A very good morning to all of you. This is Vijay Babu, Faculty of Electronics and Communication Engineering. So today in this lecture, I would like to discuss about the basic concepts of communications. All of you know about this, that communication is very important in day-to-day life. Okay, the communication systems really places a major role in delivering our information from one place to the another place. There are a lot of communication systems available. So in this lecture today we'll try to discuss about the concept of double sideband suppressed carrier. So that in short, so we can call it as DSBSC. So the DSBSC stands for double side band suppressed carrier. So this is the short form of DSBSC, double sideband suppressed carrier. Okay, we'll try to go ahead with the logic. So let us consider this is now the target is to generate the DSBSC signal. To generate the DSBSC signal, I'll try to use the DSBSC modulator. Okay, for any modulator you have two inputs, right? So all of you well known that any modulator will have two inputs. One is the message, okay, and other is the carrier. And the output of this DSBSC modulator is what I try to write it as S of t, which is called as DSBSC signal. That's it. So the two inputs, message and the carrier, are given to the modulator that generates the finally a DSBSC signal. Let us consider the message is M of t and the carrier is, we call it as C of t. Okay, now we'll try to develop the mathematical equations for message signal. First of all, let us consider AM as the arbitrary case. So let it be M of t itself, but the carrier will try to consider it as the single tone high frequency carrier AC cos 2 pi FC T. It's a very high frequency. FC is the high frequency. Okay. Now to generate the DSBSC, so what the modulator will do, the modulator simply multiplies the two signals. Okay. So the multiplication of two signals meaning is one is simply M of t and other is multiplied with what? C of t. That generate then the signal what is generated finally the mathematical form resulting is called as DSBSC. Okay, so which is equal to what is M of t? Let us consider M of t is some arbitrary signal. I don't want to confine M of t to some sinusoidal, okay, some square, some triangle, not like that. It is a general case of M of t. Any signal you can take here, and C of t is AC cos 2 pi FC t. So now this is the mathematical equation of what we call it as DSBSC. Okay, now the next we'll try to go ahead in developing the what you call power calculation and the bandwidth calculation of this DSBSC. Okay, next we'll try to go ahead with the power calculation. So before going for the power calculation, I would like to write the equation of this S of t DSBSC is equal to what is that? AC M of t cos 2 pi FC. Now I'm going for power calculation. So to calculate the power, simply S of t you can write it as M of t multiplied with AC cos 2 pi FCT. Okay, now M of t let us consider power of M of t as Pm. Okay, power of this AC cos 2 by FCT is RMS value whole square. All of you well know this. So now this is simply AC square Pm by 2 is the power of what you call it as the DSBSC. Power of DSBSC, that many watts you can write, that many watts. So here what is the value of Pm? Pm is simply power of the message signal. Power of the message signal. Okay, so now we'll try to go ahead about the bandwidth calculation. Okay, so bandwidth calculation, To calculate any signal bandwidth, compulsory we have to apply the Fourier transform. All of you know. First of all, I will try to write the time domain equation AC m of t cos 2 pi fct. Now we'll try to apply Fourier transform for this to calculate the bandwidth. So immediately it becomes S of f is equal to AC by 2 m of f minus fc plus m of f plus fc. Okay, now I will try to plot the spectrum of this S of f. How can we plot it? Clearly understand here, let this is mod S of f. I don't know the actually the spectrum of m of f. So to do the spectrum of m of f, first of all, assumption this is the spectrum of m of f, which is extending from w. The bandwidth is band limited to w. Okay, the bandwidth of the message is what now? W. Now if this is the spectrum of m of f, immediately you draw the first term. What is the first term? Spectrum of m of f is shifted to fc. So I will try to take a different color for better understanding. So fc, at fc you have the spectrum of m of f. Similarly at f equal to minus fc you have the spectrum of m of f. So this is the ds-base effect, and this value is fc plus w, and this value is fc minus w. So now bandwidth is simply given as, how can I write? Higher frequency component minus lower frequency component. However, you need to consider only positive frequencies. So that means fc plus w, okay, higher frequency component minus fc minus w. So which is equal to 2w. So this is the bandwidth of the DSBSC signal. Okay, now I will try to understand a little bit about the spectrum. The frequencies from fc to fc plus w is called as the upper sideband frequencies. Okay, whereas the frequencies from fc minus w to fc is called as the lower sideband frequencies. So that is why, as you have both upper sideband and lower sideband components are there, so this is called as double sideband. However, double sideband, but there is no carrier. Okay, then you can call it as the double sideband suppressed, double sideband suppressed carrier. So thank you for attending this session. Thank you so much.